This video just has some more strategies for solving for angle pairs. It is expected if you're watching this video that you already know what the names of the angles formed by parallel lines and a transversal are and which ones are congruent. So for my general advice is to highlight or mark your lines somehow. So consistently I'm going to try to mark my parallel lines with a yellow highlight. And then what I want to do is also mark my transversal. In this drawing for number 1, I have two different transversals. I have one that cuts across here and one over here. The one over on this side doesn't actually intersect any angles that I know anything about. But this transversal over here intersects 3 different angles that I know something about. So I'm actually going to visually ignore the other transversal and just pay attention to these 2 parallel lines and that blue transversal. If I do that, I notice that this angle here and this one down here are corresponding angles, and because they're corresponding I know that they're congruent. So I'm going to set 5x minus 5 equal to 4x plus 10, and I know that they're congruent because those angles are corresponding according to that transversal. If I subtract 4x and add 5 to both sides of my equal sign, I get that x is equal to 15. And I got that because corresponding angles are congruent. Now if I put the 15 in for x for both of these 2 angles, I should get the same value. So 5 times 15 minus 5 would be 75 minus 5, which would be 70. So this angle right here is 70 degrees. I could also check that 4 times 15 plus 10 is equal to 70. So I know that this angle right here is also 70. And that's not a surprise to me. That's what the work I did when I solved x equals 15. Now to figure out what y is equal to, I'm going to use a different property. I know that 6y minus 4, I know that that angle is an alternate interior angle. Nope, it's a same side interior angle. With the 70 degree angle. So that means that it's going to be supplementary. So 6y minus 4 plus 70 has to equal 180. Or 6y plus 66 equals 180. Subtract 66, so 6y is equal to 114. And then if I divide by y, I get 19. So using 2 different relationships, corresponding and same side interior, I was able to figure out the values of x and y. If I do something similar for number 2, I'm going to highlight the parallel lines in yellow. And then I notice there are 2 different transversals here. There's one transversal here, the green one, and then there's also a transversal here that involves the angles with x's in them. So since I know that on the green line I have same side interior, I know that those angles have to add up to 180. So 3y plus 18 plus 90 has to equal 180. And so 3y plus 108 equals 180, or if I subtract 108, 3y is equal to 70. 72. So then I divide by 3, y is equal to 24. And then switching over to the other line on the other transversal line, same thing. I have same side interior angles, so those are going to be supplementary. So 15x plus 30 plus 10x has to equal 180. So 25x plus 30 equals 180, or if I subtract the 30, 25x equals 150. X is equal to 6. And so I'm using same side interior angles twice on that problem. All right, for number 3, I'm going to highlight this one a little bit differently. I have a set of parallel, and then I have another set of parallel. And so I really have some choices on the relationship that I'm going to use. One thing I notice is that this angle and this angle here are same side interior. So when I set those ones up, I'm going to make sure that those ones are supplementary. And then I'm going to do the same thing with these two angles. They're also same side interior, so same side interior are going to be supplementary, so I will set those ones equal to 180 as well. I'm going to pause there and have you think about number 4, maybe solve those two equations, and come back after you have tried these problems. So I solved the two equations in number 3, and my work is there. And then for number 4, I used two different transversals. I started by using the blue transversal, and I said that I have 3x and 5x minus 20. Those are congruent because they're alternate interior angles. So those are congruent. And then I used the other transversal, and I said, well, I have some same side interior angles there. I have the 2y and the 30, so 2y plus 30, and the 4y, and those ones add up to 180 degrees. So y is equal to 25. All right, try these two, and then I'll show you my solutions after you've given them a try. I want to emphasize there's more than one way to see these problems, so if you saw a different thing but you were able to get the same answer, it doesn't mean that you're wrong. I first saw a linear pair made up with the 2x plus 90 angle and the x, so I added those together to get 180. I solved for x and I got x equals 30. And then I knew that z and that 30-degree angle were same side interior angles, so those ones were supplementary. They add up to 180, so z is equal to 150. And then I noticed another pair of alternate interior angles with the 2y and the 30 are alternate interior angles, so y is equal to 15. For number 6, I had a hard time separating out the diagram in my mind, so I just drew a separate picture. The first angle that I solved for was I found an alternate interior angle between these two yellow parallel lines and the orange transversal. I said that they made a Z right here, and that angle was 50 degrees for both of these two alternate interior angles. And then I also saw a pair of alternate interior angles between the orange lines, with the orange line and the yellow transversal. I saw that the 50 and the x were alternate interior angles, so those were 50. And then I saw with the orange lines and the green transversal, I saw that the 90-degree angle was in the same position as the 50 and the 40 together, so they were corresponding, and so y was 90. All right. for the rest of these, I'm going to show you my solutions, but I want you to try 7 through 10 before you look at my solutions. So pause here and then get started. For number 7, using the blue transversal, I saw some same side interior angles. So that's how I figured out angle 3 was 74. And then looking at the green transversal, first I saw a linear pair, which didn't have anything to do with the transversal, except that helped form that angle. So angle 1 was 68, and then on the green transversal, angle 2 has to be the same size as angle 1 because they're corresponding. For number 8, I added together the 71 and the 22 to get 93. I knew that angle 2 had to also be 93 because it's corresponding. I know that angle 1 also has to be 93 because of vertical angles. And then using the green, using the linear pair between the 113 and the 3, I was able to figure out the last angle. Number 10 has a lot of different variables that you're solving for. I would recommend that you just break it up into pieces and look at each piece separately. So I highlighted these 2 parallel lines. I started looking for relationships along those 2 lines only. And so I started with looking at vertical angles and linear pairs, and then I started seeing other things like here's a transversal, and along that transversal I have an alternate interior angle, so this would be 175 because it's congruent to x. And just go slowly and look for relationships as you go. There are a lot of different lines that you have to keep track of here, but I'm seeing another transversal that's going to give you a hint here. So if I highlight this transversal, whoops. I see that angle T, because of that transversal, is going to be 58 degrees because it's an alternate interior angle. So it looks like a lot, but it's really just look at little pieces at a time, and you'll get it. All right, thanks so much. Bye.